Well, hello, everyone. Welcome. My name is Katrina Searing. I'm the Associate Director of ESF's Open Academy. I'm joined today also by our graduate assistant, Daria Getcha. She's been doing a lot of work behind the scenes as well. And if you're coming to the conference in person, you'll be able to meet her. So thank you for joining. This is the 4th annual New York State Mass Timber Symposium happening through the month of February. And really this program helps us to build capacity and learn about all that this new approach of mass timber building has to offer in its design and delivery. And this symposium is hosted by the SUNY College of Environmental Science and Forestry. So you should be able to see a little tile of me as well as the PowerPoint presentation, and that'll be helpful as we go along today. So as always, we like to begin with where we stand, that I and others have the privilege of joining this meeting from the ancestral lands of the Onondaga Nation, the center of the 6 nations of the Haudenosaunee Confederacy, who we honor for their many contributions, including the original philosophy and practice of environmental stewardship, and who we'll still be learning from today. So some general information for our presentation today. This is the same Zoom link we'll be using for the next one as well. So if you have it, you can just pop it right in your calendar. We're going to ask that you stay muted throughout the presentation. If you do have questions, please enter them in the chat. We will have a facilitated Q&A with our presenter at the very end of the presentation. This presentation was not approved for any professional credits, but we still can offer certificates of attendance for your self-reporting. So hopefully you've asked for them when you registered, and we're sending those out right after the presentation. You should have got them last time right afterward, about 3:30, 4 o'clock-ish. And then after that, we send out a feedback survey. We'll send that out this afternoon as well. Sorry, if you tried last week, the link was actually the wrong link in the email, so it didn't appear at all. So thanks for some of you let us know. I appreciate that. I was able to get that fixed, and we sent out another one the following day. So thank you very much. And we really do appreciate your feedback. We send it on to the presenters. They value it. So thank you very much. Just takes a couple minutes. I think there's 4 or 5 questions. And always, if the presenters have granted permission, we're making slide decks and the recordings available. They'll be available shortly after the conference. We're on Facebook and on Twitter using NYS Green Building on Facebook, and at GB Conference on Twitter, we're using the hashtag Mass Timber New York and NYSGBC 2023. So if you want to tweet along or give our presenters some shout outs, we appreciate that also. All right, so we are in our second of 3 presentations that comprise the 4th annual New York State Mass Timber Symposium. This one is by Dr. Paul Kremer, who Dr. Cravella will introduce in a moment, on building communities above our cities, the rise of hybrid timber vertical extensions. And I hope also that you already have this presentation for next Wednesday in your calendar. Sandra Lupian from Mass Timber at MSU, Michigan State University, will be with us in harnessing engagement, research, and policy to build mass timber momentum in Michigan. And just to say to our friends and colleagues at Michigan State University, hope you're doing okay after recent events there. So sending you hearts and support from Syracuse. So it's wonderful to have seen these programs come together and build, and really great energy around so many of these things. So right now you're in this 4th annual New York State Mass Timber Symposium that is going to go into the deep energy retrofit workshop that is reaching or at capacity. That'll be right before the conference on March 1st. We have some space for folks to attend in person and virtual attendance as well. We're soon reaching capacity for that, but that's going to be great. And then at the actual conference, March 2nd and 3rd, you can also attend in person or virtually. We'll have concurrent sessions, keynote speakers. Taylor Cabot from Timber Lab will be there, and Samantha Pierce from New York Homes and Community Renewal will be there. We have great panels on connecting our communities across the state with infrastructure and highways and the impacts of them, both constructing and deconstructing them. and another one on women in green. And we're getting ready to announce our panelists for the Women in Green panel as well. That is a joint effort of ESF and the New York Upstate Community for USGBC, and our own campus president, Joni Mahoney, will be moderating that panel. We also have a student poster competition with prizes, which is awesome. That's happening March 2nd during the reception, and a clean energy career fair. So if you have jobs open in clean energy careers, we will have a spot for you at the career fair. If you know someone who's seeking a career, we have spots for job seekers and also for education and training providers as well. So more on that after the presentation. So it's my pleasure to introduce my faculty colleague, Dr. Paul Krivella. He is Assistant Professor of Sustainable Resources Management here at ESF, and distinguished teaching faculty as well, and on our Conference Advisory Council. Really a pleasure to know and work with. So welcome, Dr. Krivella, who will introduce our speaker today.
Thank you very much, Katrina.
Oh, Paul, I muted you. Sorry, I meant to mute myself. I need you still to unmute, Paul. Sorry.
Here we go. Thanks, Katrina. And thanks for everything you've done. Very fortunate to be able to work with Katrina to help deliver this conference. As she indicated, there's actually going to be a mass timber track as well as part of the in-person event. So that will be a follow-up for these virtual sessions that are coming up. So very pleased to be able to actually bring back Dr. Paul Kremer. He has presented previously for us, and it's always a treat. Paul is a business leader. He works as a consultant. He's very active in academia and research. And really, he combines all of that with thought leadership for what is happening in the AEC industries to make sure that the nexus between sustainability and mass timber construction is optimized. So Paul has a deep understanding of managerial and organizational issues. He also has a holistic understanding of technologies and the global drivers that are reshaping the construction sector worldwide. Paul worked first as part of a manufacturing team, overcoming some of the initial challenges to deliver some of the very first mass timber projects in Australia and New Zealand. Since then, Paul's moved forward in a number of roles, helping to overcome challenges to scale the work in prefabrication, digital fabrication, and throughout all of this, he's remained focused on ensuring that academic research produces impactful results for society. So he's a pleasure to have back. He's a founder of the Mass Timber Construction Journal. He serves on the International Advisory Committee as for the Council on Tall Buildings and Urban Habitat. And he also hosts two very entertaining podcasts among his many roles. And so with that, I'll turn it back over and let Paul take the floor for today's presentation.
Thank you very much for the invitation to come and present today. Good morning, good afternoon, or good evening, wherever you are in the world watching this presentation. I hope you enjoy it, and it is a pleasure again to be at this event. I came last time, it was 2 years ago, so it was really good to get back. So this presentation will be on mass timber vertical extensions and I guess it's trying to resolve the urban densification problem, which is a significant issue in major cities around the world, including in New York City. So it is something that we do need to consider for the future, and we hope that this presentation gives you a sensibility about some of the things that urban planners or architects or developers might consider when looking at buildings in the future. And so really what we're talking about today is our urban densification problem. But before we get into that, just for the uninitiated, cross-laminated timber is one of the major products within the suite of mass timber construction products, and is a significant hallmark, I guess, in US history, because The first patent that we could find actually comes from Tacoma in Washington State. And here it is. It's looking at using the improvement of a timber resource to laminate material together to create solid section panels. And here you can see the original patent by Walsh et al. And it was done in 1920, so it's over 100 years old. 1923 is the approval, so August this year, it'll be 100 years old in terms of the patent. And mass timber is really not just about the material, it's about the process as well. And so back in 2015, I wrote a paper, it's quite a seminal paper on all of the utility of mass timber. And as you can see here, not all of it is exposed. However, the material really replaces reinforced concrete and steel structures. More recently, we've moved away from being, purist in our designs to hybrid systems. However, the genesis of mass timber is really around this renewable timber technology that then has this prefabricated process that wraps around it. And that's some of the great utility within the solution itself. And so what's been happening in global supply chains? These are 2021 figures, 2.1 million cubic meters of CLT. Don't ask me to convert that to board feet or square feet. It's a lot of material being produced around the world, and it pretty much spans across the globe. There are more plants coming online. The latest one is in Uruguay. There's one coming up and planned for in Chile. And so we're seeing this global progression. 10 years ago, it was a very, very different diagram that you see in front of you. But today you can see that it's actually taking a hold. Now, the question has been, how much timber is that compared to, say, wet pour concrete that might be used in construction? Well, we estimate it's probably around about 1.6% when you include all the glue laminated timber, which actually has been around for a long time. And CLT, or cross laminated timber, and Dow laminated timber, and nail laminated timber, all these other types of associated mass timber products have been relatively recent. So there's some three important numbers I want you to understand. They are 39, 28, and 11. And that is because building and construction is responsible for 39% of the carbon emissions around the world, and with 28% of that being operational emissions. The remaining 11 comes from embodied carbon emissions. That's the carbon that's done, used in the production of the materials, construction, processing materials, concrete, steel, even mass timber products throughout the whole building life cycle. And so really what we're trying to do is meet those COP26 and COP27 targets that are in accord with the Paris Accord. Everyone's committing, governments are committing around the world to try and get a more sustainable way to produce buildings. And so we see mass timber as being a great virtue product for that. The other really cool thing is that we don't necessarily have to see mass timber replacing concrete and steel, but if you do, there's a really great carbon equation. And that is that for every cubic meter of concrete, you have a cubic meter of timber, and as part of that, you actually then have 1 cubic meter of CO2 that is saved as well. So this is because timber sequesters carbon when it's a tree, a plant, and it's growing, and it stores it within the timber. And so therefore we have this storage system, a natural storage system. And the carbon storage, I guess, continues because when we add in place the process that wraps around it, and we look at things like the traditional design and construction processes, we see this picture, and that is really around a difference in the way that we produce. You'll see on the top line here, the design is sort of 50-50, maybe a little bit more. In the traditional sense, that's upfront design. Of course, in traditional construction, design goes all the way through, almost to the very end of the construction process, as architects come on site and continue to evolve and change and work with engineers, and the building and structure through an in situ build can alter over time. In prefabrication, it's different. We do have a longer design phase up front because all the decisions need to be made, especially for the superstructure, which is what mass timber is really producing, so that we can have full, final and frozen, a cutoff point, then we can actually produce the building in a factory and send it to site. Now, of course, if you want to have changes on site, get a chainsaw out, use a saw, use some drilling or coring equipment, and you're able to then create penetrations. But in fact, the design and the whole concept of efficiency comes from having a longer design phase, but a shorter construction phase. And that saving at the end is not only a carbon saving, as we mentioned before, but it's a preliminary saving, it's a site cost saving, it's a crane saving, it's a labor saving. The time is reduced. Now, the ideal is 30%. The reality is somewhere between 0 and probably 20 to 25 in a realistic sense. And it becomes more certain with practice and time from the players who are involved in the particular project. So an iterative process creates knowledge. The knowledge translates into the savings. So what does it all mean? Well, if you're sitting there and you're thinking, well, why would I use mass timber? Well, one very compelling reason is that when we do the numbers and we have a QS who has a really good understanding about what's going on with cross-laminated timber buildings versus concrete construction, you can actually see the differentials here. So these are live projects that were done in Australia, and you can see that there's a total cost for the project in the double bottom line, and you can see that there is a cross-laminated timber building costs 4.4 million in Australian dollars. The concrete equivalent was 4.6 million, and the minus 6% differential saving was actually in things like adjusting the columns. We didn't need to have the same material substitution. We could adjust the columns and make that work. The other thing that was really interesting in here is that whilst there was an addition for most of the other things like the floors, the stairs, the roofs, etc., when you add back the preliminaries, which is actually the time difference savings, you put back in 287,000 Australian dollars, you then get to see that there's this positive differential to the mass timber. So without the prefabricated process, mass timber does not necessarily stack up on a material compared to material basis. So do not base it on that. Base your assessment on feasibility based on the total project cost and what it would have been if it was in more traditional materials. What about digital solutions? So if we want to get this mythical 30% and we want to make sure that that's a truism, then how do we use digital technology? Well, this is one of the biggest challenges, and it's actually been met quite strongly by industry. We have BIM, and BIM is a software or a program, or it's a model. However, BIM can also stand for Building Information Management, and information is powerful when it comes to building because it creates certainty. So here is the Catalyst building in Spokane in Washington State, and this is the Katera job. 37,000 or 3,700 metric tons of CO2 were saved and assembled using Katera panels. And what's really interesting is that the Revit model and the actual building are remarkably similar. So here's the Revit model, and we've built the building in a digital, almost a digital landscape before we've actually constructed it on site. But it's really important to note that it's also this digital building which goes into the fabrication of products, which then constitute the building when it gets assembled. And so here you can see the typical floor system. They've actually laid out how the services are going to work. They've looked at the orientation of the panels. They've looked at the width. They've looked at doing what's called panelization, which is mapping out where the panels will go relative to the cores, etc. They've then converted that into effectively shop drawings and construction drawings. So now it's gone from this Revit model from an architectural form, place and space concept to something that can actually be constructed and handed over to a constructor to be able to do that. Then you have the structural analysis modeling. So here you have all your beams and columns and your intermediates all being put into the model to make sure that the forces and stresses and loads, etc., on the building are analysed and the sequence again is considered. Then you overlay the panels on top of that and add the facade elements. And you can see on the roof structure, there's like a services amenities section that's being built as well to probably house air conditioning and other systems that might sit on the top of the mechanical services for the building. They then went and worked out, well, what are the zones going to be? How are we going to deliver it? How much can a truck actually bring to site? And how much can we relatively expect to do in a day? And so these are those drawings. These are given to the constructors to be able to say, this is what we're going to do. This is when you're going to receive things. This is the sequence in which you're going to receive them. And then the final building then finally gets built. As you can see here, some very large glue laminated beam systems, ribbed floor system as well with CLT panels sitting on top of it. And you'll actually notice if you look down on the first picture, the larger picture on your screen, that there's actually been used light gauge steel framing. Now, one of the advents that's sort of occurred when we've moved away from being purist in the way that we use mass timber products is towards a hybridization and the use of steel systems, or it could be a light gauge steel or a timber framing. They will actually save you money and actually reduce weight as well. So you can use a mix of materials. Primarily, mass timber is used as the superstructure. It's on the critical path. You need to make sure that that's in place because everything else that follows from that is dependent upon that structure being available to everybody. Here you can see the facade in, and again, the facade's actually got mass timber elements to it, the external wall with the windows inserted in it, and it is a very, very impressive looking project. And here's some more construction photos, and you can see the facade from the outside. And the building goes up pretty quick. It's assembled in a fairly quick amount of time, and it is a wonderful looking material as well as a architectural design. So the other problem that we actually have that mass timber can be very, very useful in supporting is not only this carbon story and this great prefabrication story and this great software and digital twin story, but is the story of urban densification. It is the challenge to try and overcome the amount of populace that's sitting within our cities, and it's continuing to grow. It's not abating. In many modern cities, people work in the central business districts. They frequent the cities. There's a vibrancy there. It's a desirable and affable place to live, and it is becoming a real concern as to how we're going to fit everybody in. Now, in Australia, the land creep where the metropolitan area is expanding in, almost centrifugal rings from the center of our CBD further and further out, means that, the trip into the city now is 50 or 60 kilometers to get in. And the land pricing is just going through the roof. It's, one of the most expensive places to live is actually in Melbourne, my hometown. And so, I know it's also very similar to New York City, to Manhattan Island. So how do we resolve this? How do we work this intractable position where we've got an increasing desirability to be in these populous areas, to make it affordable and make sure that people can actually have some space to actually live? And some of the statistics are quite interesting. So for the United States and for Canada, you can see here Los Angeles has a densification listed there that's sort of around that sort of 4,500 urban land areas, square kilometers. And you look at New York, it's double plus. It's almost hitting 9,000. So densification is significant in places like New York and Los Angeles. And so it's important to try and think about how do we resolve this problem. One of the considerations is really trying to work out how do we make better use of the buildings, the land, and the structures we actually currently have. So here you can see a number of concepts. The top one is really about raising the roof. How can we extend on top of an existing building to provide more space, to give it greater utility, to change the accommodation or the work office space above to be able to situate more people in the same space. So now the airspace above the buildings becomes extremely valuable for development and development purposes. Of course, it's contingent on the existing building, and we'll get to that later on in the presentation. The other one in the middle there is the infill, urban infill land areas. Along the railway systems here in Australia, there's a lot of space that's dead, and the small parcels of land, they're now being used by people that are actually using mass timber products because it has a high frequency density that actually provides some block out for those noises. It's not so good in the lower frequencies, lower hertz range. However, there's sound deadening and protection systems that are being applied to mass timber buildings in these urban infill land areas that allow a building to be built within meters of a railway system. And in fact, we're elevating our train system as well, like you have in a lot of areas in the United States. And so now land is becoming available. So we're looking at urban infill or housing infill. Then you also have this, a block of land with a house on it, and we're splitting the land so that it actually now has a capacity for another occupancy for the same land space. And those parcels of land which can be split and have another, fully detached or semi-detached building alongside it are very, very popular. They're expensive. They're almost as expensive as a new block where you do not have a neighbor abutting your building, but certainly they start to add value to the existing building structures that are already existing in society and how we address this issue of urban densification. So Andrew Sutton has decided that he is going to do something about this problem, and he started up this crowd-funded urban densification project. You can see the URL there. If you'd like to take a screenshot, you can go and have a look at Andrew's work. It's quite a remarkable feat. And I want to just explore the concepts a little bit further before we move into something further in the presentation. So it is effectively about these walkways and structures which then can supply greater housing opportunities for people that live in highly densified areas. And here's one of the densification solutions. This is a community, and the proposal is to have a pedestrian network that's woven into the existing fabric of the cityscape. And it then allows for space to be provided either above or below or beside this walkway. They're creating these voids, and these voids can then be crowd-funded, developed. So then more people can actually take an opportunity to work in these cities. And it's quite an amazing, combination of working on top of existing infrastructure, working beside existing infrastructure, but creating a sense of community and flow through the project. And here you can see the aerial view for it looking down on the plan. You can see it actually covers many blocks within this particular city, and the walkways are quite large. So they're creating these sort of places and spaces for people to engage and interact and really try and find some commonality in the way that the community comes together and flows, and resolving the urban densification problem. Well, people have done this before. People have looked at vertical extensions. They haven't looked at it the way that Andrew has. However, they have looked at vertical extensions, and some of the notable ones that we've looked at recently in our research are these extensions on top of existing buildings. So this particular building is a brick building, concrete and steel and brick, and it was assessed to be able to have 2 more stories. And as you can see, there is an external lift core which runs up the side of the existing building into the new building. And you'll see that there's also some quite large first floor space. That first level is quite a tall level compared to the one on the top of it. And you can see that there's an amazing, I guess, meshing of more modern architecture with the traditional period architecture for this particular city. Another one is the green section, is the vertical extension on top of the sort of salmony pink color. This particular project had a very different construction material used on top, so it was light enough to be able to extend on top. And it's, again, it fits within the urban architecture. You have a look at that building and you might not necessarily know the story, but if you looked at it, you would just think it was a very, very clever use of color to discern between potentially higher grade, higher stock, higher quality residents at the top versus the ones that were down below. Or it could be residency at the top and workplace and space below. But looking at it, you wouldn't necessarily tell that there was a vertical extension being placed onto it. Another unique view is this almost like Dutch or Netherlands type concept of jutting boxes coming out of these large roof structures. The architecture here is almost acting as if it's the roof that sits on top of the existing brick building, and it's actually an extension. So there is this space that sits between the existing building and the new structure that wraps all the way around the building, and then you move into, it looks more like, the building has been repurposed from, say, offices at the existing building into residential accommodation, and then the residential accommodation's been extended above. And so this is a great use of vertical extensions in this particular situation. Back to mass timber and timber more generally. Timber is only 20% the weight of concrete. It is lightweight. It's one of its advantages. It's one of the things that makes it unique. And back in 2016, Metzer Wood out of Europe decided they were going to create a competition. Michael Green was the inspiration. He did his talk, TED talk on tall timber buildings, and that inspired Metzer Wood to create this particular competition back in the day, like we're talking 2016 or thereabouts. Metzer Wood don't produce mass timber products such as CLT and glulam. They produce things like LVL, and LVL is a mass timber product. We've categorized it as a mass timber product. And so really it was about how can we build an extension on top of an existing building to build city above our cities. And so this is the concept shop that came forward from the particular competition. Some of the more innovative ways was to actually take the Colosseum and give it a facade and wrap it around. This was a very, very innovative use of a timber system to really promote the Plan B Metzer Wood competition. If you look very carefully on the bottom level of the Colosseum, you'll see the Metzer Wood green logo. Very, very great ideation to be able to come up with this concept by wrapping the Colosseum. Great artsmanship as well from the person that did the graphic design. And some of the entrants actually did something very similar to those previous buildings we saw that weren't using necessarily timber, but using more traditional methods. Here you can see, looks like there's an apartment block and they've extended on top of that using timber to get 2.5 stories, or two stories, 1.5 stories on top of the existing building using timber. The one over the rail line is quite important. This is actually something that will happen. There will be buildings built above transit systems and using timber to go above that. It's happening in airports above car parks already. So this is a trend that's growing. And the one in the very bottom corner that's a very creamy color, you can see it's quite a monolithic structure. It's quite ominous. and it bridges across two projects. And this particular project was quite an inspirational part of the research that's just recently been undertaken by the team and myself that we'll be talking about very, very soon. And one for all of you in New York State, New York City, Manhattan. You know, we probably won't see this happen, but it was a great talking point at the time. And another one that was iconic was to try and extend on top of your other iconic building that sits in New York City in Manhattan Island. And it was a very innovative talking point as well. People were quite in raptures about the fact that we could potentially do this. Of course, these weren't necessarily competition winners or entrants. It was more concept to try and provoke thought around how could we vertically extend or put additional buildings on existing buildings. So since the competition and since the original traditional extensions that you saw, which were quite, you know, small, 1 or 2, 3 stories maximum, there's been further developments. And certainly in Australia, the first vertical extended building was this particular building. In the distance, you can see Melbourne City. This particular building that we're standing on top of now in the image is actually Monash University. So it's a university I'm currently an academic at. This is on top of the business and economics building in a place called Caulfield in Melbourne in Australia. And as you can see here, there's very strong steel transition structure being built. And on top of that are CLT panels. Those CLT panels are some of the first panels to be assembled in a project in Australia for locally made CLT product. And the building itself is about 9 or 10 stories tall. And what we're extending on here, the first project we extended on, was a 3-story project, 1 story plus a double height void area for like a lecture theatre. And there's a stairwell or a column system that goes all the way up to the very top. And you can see it here in this particular shot. The big yellow box that you can see there is the finished building. That's actually the stair system with the cladding that's on it. The sort of yellowy gold created almost like a beacon for the building, so you could actually see it standing out on top of this existing academic structure. And as you can see on the other side, there's an in construction shot. We've got props here holding up CLT double height wall systems, and you can see the crane just in the foreground there. And where the photo is taken is actually the car park, which sits adjacent the building. So you could get really close up with your camera and see exactly what's going on at a safe distance without actually having to be on the building itself while it's being constructed. And here's the final shot again from that car park. You can see the particular building and how it was designed with almost like this scale type facade structure and a linear sort of facade structure that sits in the top in this beautiful yellow color that's almost like this iconic beacon that sits there and provides this comment to society that, you know, there's this new thing that's sitting on top of this existing building within the university. The university went on to do more structures. It did its first mass timber passive house building, which was a student accommodation building down in what it's called its Peninsula campus, and won a lot of accolades and awards. However, what people don't know is its first project was actually this vertical extension on the business and economics building. Another notable project for us was 55 South Bank. 55 South Bank is the largest, tallest vertical extension in the world. It is an iconic building because of the feet and the magnitude to which it actually extended on top of an existing building. And it was a privilege to actually be involved with the team who were involved in the inception of the engineering design, all the way through to the supply of the project. The majority of the material came from Europe. However, the local manufacturer, XLAM, also secured the roof structure. And here it is. This is the, I guess, the rendered documents from Bates Smart, who were the architects. You can see here that there's an existing building that's probably about 6 or 7 stories tall. And then on top of it is actually a 10-story timber extension. And the extension's actually a hotel. It's the Adena Apartments in South Bank. The original building is on one of your slides there. It's the Data 3 building. You can see that it's the sort of 6-story concrete building with this sort of inset top level. And then you can see on the other image the completed building with its new building and signage on top. And that's contrasting the two images, the before and the after. The building was quite remarkable. You can see here that there's a BIM model that really looks at the foundation and looking at the way that the foundations will work. There you can look at the transfer space that sits between the existing building and the new building. In fact, the transfer space was increased so that they can actually put a pool in that transfer area, as well as house all the mechanical engineering equipment that needed to be used for air conditioning, etc. And then they created a platform, and then on that platform was the 10 stories being built. At the back of the building, you can see 2 cores. They're used for bracing, but they're also used for the lifts. So the lifts are actually sitting at the back end of the building. And here's some in construction project shots. You can see the extension of the building using this blue fabric to prevent materials falling to the road below. Very difficult site to navigate to get materials in. The cranes were put into place and needed to get full coverage of the building to be able to assemble the panels. The panels were created in a model, and then they were sent to Europe. The panels were then produced in Europe, containered back to Australia and assembled. Again, the roof structure was done locally.
Hi, everyone. I know the video just stopped, so I'm trying to figure out if, I don't think it's over, but it did seem to snag.
No, it's certainly not over, but if you want to put the slides up, I can finish the rest of the presentation if you want. I'm up now.
Dr. Kremer, you're on. Do you,
Yeah, just if you'd like to put
you
the
have an
slides
idea?
up, please. Yeah, that'd be great. Yeah, sorry for the intrusion, everybody.
see you, but I have not heard you yet.
You can't hear him, Katharina? I
Let me
can.
try to pull up the video outside of the PowerPoint.
I think he's just asking for the slides and then he'll narrate if we can.
Yeah, correct. If everybody else can hear me, can someone just give me a thumbs up or something?
Yeah, you're coming through loud and clear, Paul. I think
Perfect.
everything's on our end.
Thank you very much. Thanks, Joe. Appreciate it.
Consider this your commercial break.
Yeah, and we were right at the most exciting part. We're about to get to the
still
big
cannot hear
project.
you.
So.
It seems that Katrina can't hear anybody right now, so there's something happening with her audio.
I'm sorry. Can other people hear? Oh, okay. It's just me. Okay, sorry, I'm the one who can't hear. Okay. Sorry, so sorry if I was talking over someone. I don't know why I can't hear.
So I just let Katrina know that if she puts up the slides, Paul will go ahead and narrate for her. I did that through the message center because I think her audio has just completely disappeared.
Actually, if you give me the host, I've got the slides here. So if we could get a message through, that would be good.
Okay, Paul, I think you should be able to host it now. Why don't you check?
Perfect. Got it.
Yep.
Apologies, everybody. But we'll take off where we were before.
If I think I'm back, I can hear you now. I can advance slides if you like. It's up to you.
No, it's okay. I just had it from the slide that I wanted to go from, but I actually then just skipped through, which was very, very silly, and said play from the start. So I want to play from current slides. So I'll be fine. Thank you. Here we go. So 80 M Street, you're probably maybe familiar with this. It's in Washington, DC. And it is a vertical extension on the old WeWork building. And that was really important because I think during COVID times and a few things that concerns with WeWork were allowing this building to actually happen. So he got Cole with the architects and a great team that were behind this. And they looked at many massing models to try and work out how they were going to create this particular space and get the most utilization out of the particular building. And they chose to use an offset penthouse. So 2 stories plus a penthouse, slightly offset, which allowed for the canopy structure to go in the front of the building, as you saw from the render. The really interesting thing here, though, was because there was issues potentially with trying to get code compliance and testing systems, they extended the central core of the existing building up into the new space. And this provided an opportunity that as soon as you walked out of the CLT or mass timber floor areas into the new core system, it would actually just be traditional systems that are available in any building that have been certified and are under regulation. So they were able to get around the problem of, do we do something different in the extension of the core and the services and the way that egress would actually occur in the building, or do we do it the same and actually just work out a fancy way to put mass timber around that core? And that's exactly what you can see here in the plan. And that is that central core area with the CLT floor system spanning out to the side. And under construction, you can see impressive glulam beams and columns and floor systems being CLT, a beautiful product and a great little project, and certainly a testament for what's happening in the US. Sorry, Jeff Spiritos, I don't have any images of your extension, but next time, please do let me know and I can chuck them in. But that's all one building on top of another building. And we looked at Andrew Sutton's work around connectedness. And so what about building cities that combine and connect with each other? So we met the challenge of trying to work out how do we put communities above the cities, not just people living in a building or working in a building and it's an extension building. We wanted to try and create a different approach, a more sustainable approach to planning. So the Melbourne Mallee is the project. Mallee is actually an Indigenous term, and I'll explain what it means very soon. But the project was funded through CTBUH and partners, and Deakin University, which was the university I decided I'd be affiliated with in this particular project, as opposed to the other affiliations I had. We undertook the 2020 seed funding. We got this particular project across the line and we've been working on it. We had disruptions through COVID. We had people that moved from Australia back to the United States and the project team, and it took a little bit longer, but we were really pleased with the outputs. The project team is here. You can see all walks of life. We have engineers, modelers, we have academics, we have people in the industry, all coming together to try and work out exactly how we're going to resolve this problem of communities on our cities. But importantly, we had to think about the problem from a number of factors or domains, and some of those factors and domains exist here. The first group of factors and domains were really about the city and the country itself. So what does the particular country or city view in terms of the stock it holds currently that might have the capacity to have a vertical extension on top of it or an overbuild, and the distance between those buildings. So it's the distance within the city block and potentially between city blocks, the height differential between the existing buildings that you select in the sort of pool or population or sample that you pull out of that particular city, access to that building. The 55 South Bank and WeWork buildings had sort of space around them to be able to maneuver. Is that always going to be the case, or will there be barely meters between the buildings with a small laneway running through? The the age of the city. So do they have modern new buildings that potentially have bolstering or reinforcement within them? And then obviously any heritage overlays, anything that needs to be considered where you cannot necessarily alter or adjust the building structure itself. Potentially internally you can, but maybe not the facade. And what does that mean? So that was the sort of first group of factors. Construction expertise is really about the progression of the technology, specifically modern methods, specifically prefabrication, and specifically to do with construction expertise in mass timber. Environmental factors were really important. The first one we looked to was the seismic volatility aspects. We would need to be concerned about how we were going to address those issues, even though mass timber has a great ductility and is great in a seismic susceptible area. We still needed to work out how we were going to get around that. And it wasn't actually just the one building, it was multiple buildings, because we were going to have these connected communities at height. The next group of factors was land cost. The scarcity of land drives up the land price. That means that the airspace above becomes more valuable, had greater utility. And so instead of sprawl, we wanted to go up, and that resolved the densification problem. And the last two factors were really important: the stability of the government. So knowing that there certainly was going to be an accommodation for new codes, new ways of working, acceptance of different delivery and development pathways, revitalizing cities by looking at them in a different way. And then the last one was the sustainability commitment. The Conference of Parties 26 and 27 really created a genesis where governments around the world are meeting or trying to commit to and meet those Paris Accord targets for CO2 emissions and the reduction. And so mass timber then becomes a very good utility to support that particular endeavour. And that's why we looked at these domains. So we didn't do it in isolation. We actually had some good thought. I'm not going to read all of these, but these are the considerations for the existing building and the new build, certainly underpinning for the foundations, existing structure strengthening, transfer structure services, and the disruption to the existing tenants. In the 55 South Bank project, the tenants stayed in the project. It wasn't always rosy. they did make complaints at times. However, they did stay. All the other factors on the other column really relate to what happens on a new build anywhere. But the main one is really about how you're going to get deliveries, how you're going to get prefabricated elements to site. And we needed to think about all of those in totality when selecting buildings for our concept that we came up with. The other thing was to work out, well, what are our bridging systems going to look like? So we actually designed a bridging system. We actually looked at limitations. We engineered the whole system. We didn't engineer it in purest mass timber. It was not possible to do so at the spanning distance. So we used a hybrid approach, and we certainly took from the expertise from existing projects like the one that's pictured and how that would work specifically at height. And we were able to come up with some engineering schematics. And we basically mocked up or started to concept design what structures might look like. Here you see two grey buildings, existing buildings of differential height, and you have this transfer system on the timber tower that's 10 stories tall. So that pretty much mimics what's happening at 55 South Bank. So we already had Nick Hewson, who was the engineer on that project, was on this project team. So we already had the engineer that could tell us exactly how to build a 10-story building on an existing building because we'd already done it. We then had the sky bridge going between these two structures to the other existing office building, where we have an extension of that existing office building with a timber office building. And so now you can start to see that this concept starts to take shape. And we actually were able to model this and make sure that it was a feasible concept. So Melbourne Mallee actually is a group of eucalyptus trees. It's an Indigenous Australian term, which means to have a cluster of trees. And the trees actually provide to the ground area sort of 30 to 70% shade for the Indigenous communities to come and rest under during the day, or to make camp. And so this sense of community around this gathering of trees was really one of the inspirations. Now, I have to give credit here to Professor James Doffler, who was on loan to us from the United States, that worked as a professor of architecture at Deakin University. I believe he's now in Florida or at Auburn University or somewhere around the world. I haven't caught up with him recently, but he came up with this concept in his time in Australia, and it was a great concept fitting this particular proposal. And so we set out looking at what it might be to build multiple buildings on top of existing buildings. And we chose Melbourne. We chose Melbourne because it actually meets all of those criterion that we actually set out to provide on that scorecard that you saw earlier. It also provided us a sensibility to be able to go and physically go and see the sites to see whether this is a plausible thing that could happen. Of course, we couldn't assess the existing buildings, so we actually made sure that we had assumptions that met the criterion to come up with a feasibility concept. And certainly in the detailing of this, you can see that it's quite an ominous structure with three interconnected buildings, all of similar sort of design and shape that somewhat mimic that eucalyptus tree gathering site. And we thought about the spaces that sit beneath these. What are these transfer decks? On 55 South Bank, they put a pool in there and they had their services. Well, we said, why don't we make this concept something more community oriented? And so we created spaces that actually provide this sense of community as you walk in. And between the facade system, this curtain wall system, and this internal building, we had these open spaces for community activity and traffic flow as well. We had to consider airflow through the building, so we looked at that. We looked at all these different zones and how that would actually exchange air inside these particular structures, and how the stacks would flow. And in fact, this is very similar to termite mounds. The airflow in termite mounds is very similar to what you see in this particular action with the airflow coming through this proposed building. And we also wanted to look at the forces acting upon it and how that would then protect these, what we called sky gardens. And we termed the lobby, which was the transfer space, which we created like large stilt areas, the sky lobby. So we had sky lobbies, we had these bridge connection systems, we have these amazing internal facade systems and these sky gardens all working together in concert with the building structure. And this is the location, that is the river system that runs through Melbourne. This is actually from Google Maps. This is the typology from the the city of Melbourne, and you can see here the buildings in various states of structure. They have got the first floor, so the sky lobby up, the second one's the foundations for the sky lobby, and the third one's just starting with the transfer steel on top of its deck. And as you move up, the buildings start to take form and shape, and the bridges are now in and the platform construction's working. You'll notice we use CLT cores. We did not use concrete or steel cores in this particular proposal, and the curtain wall is chasing up the building as it goes. And when it's concluded, it sits in the space. Of course, it's fully furnished with its eucalyptus trees sitting out the top of in the sort of terrace areas on the very top level. Those terrace areas could also be spaces for people to meet and have communal activities, etc. And yeah, it's a very important concept for us to try and validate this particular concept of how do we build communities at height. And so some more facade shots. The glass curtain wall is sort of transparent to allow a visibility of the structure and the sky gardens within. And you get all these different views, and it's quite a beautiful building. We tried to create a sense of, you know, what could be for the future. And we think that the concept certainly holds weight. The trouble will be trying to get developers that own these disparate buildings to agree to work together in a collaborative sense. But hey, that's mass timber construction is all about collaboration. So we're trying to work out how we can do that. And as you can see from the river view here, looking back onto the structure, sitting in the cityscape, it nestles in quite well with the buildings that are around it, which are of a similar height, and they are without vertical extensions. The sky bridges there, you can see, are not necessarily at the upper levels. We wanted to create those community spaces at the base level where there's these transfers from the existing buildings. But overall, I think the concept holds some water, and we certainly think that at some point in the future, someone will take the inspiration and support a project like this. And as you can see, the underside here, we used a hybrid of materials. We used steel as well as the timber and concrete. We didn't believe that it was a purist CLT project. We had to use a hybridization of materials, which is becoming more and more popular, using the right material in the right place for the right purpose. However, it's starting to take shape, and here's that sort of sky garden community pathway walk area where it's insulated and isolated in this particular location. And on the very rooftop terrace, you can go up there and enjoy the city views while enjoying some of nature and having, you know, a greenery on the top of your building, and you know, meet with friends and family and new friends and colleagues and visitors, etc. And as it sits in Melbourne, this is actually Melbourne. That big yellow and red building in the middle there is Flinders Street Station. It's our train exchange in the middle of the city. The city block is to the one side of your screen, depending on how you're looking at this particular image. And you can see the new vertical extension community area nestles quite well into the area just above the railway station there. And there it is, located in Melbourne along the riverside there. That is Melbourne CBD, and it is a beautiful art spire that sits in the middle there. The domain gardens here, where there's lots of concerts and community activities happening. And then if you look across the river, you'll see the Melbourne Mallee project sitting nestled in the public space there. And that was it. Thank you. Even with the interruptions we got through, just some follow-up points. If you want to catch up with me on the Mass Timber Construction Journal on LinkedIn, the Mass Timber Construction podcast, there's over 150 episodes now with people all over the world talking mass timber projects updates every week. You can catch the podcast, and just like to say thank you to Deakin University, Melbourne University, the team that sit behind me in the journal. My contact details are there. If you'd like to take a screenshot, certainly please do, and happy to take any questions.
Well, thank you very much, Dr. Kremer. That was wonderful. A little bit of a hybrid presentation, both a little bit of video and having you live. So that was wonderful. And sorry again for the glitch. That's a first, but these are the learning experiences that keep us moving forward. So thank you. We did have a couple questions for you in the chat. I think One was already answered by Paul Cravella about insulation R values available in CLT. Can they include a foam sandwich? So Paul's already answered that, but if you want to speak to it too, please feel free.
Yeah, certainly. So the R value on 110 millimeter, so sort of 4-inch to 5-inch thick CLT panels, about an R1 value. That's its natural fiber density, and it depends on the species. Certainly the species in the US would be around that 450 to 550 to 600 kilograms in density. Sorry, I don't know what the conversion is in imperial. However, it holds an R1 value for around about 5 or 6 inches, 4, 5 or 6 inches. So that would be work. And you can also adhere the sandwich panel to the actual CLT panel in a post-production process in the CLT plant. So once the panel's gone through its pressing phase, gone through its CNC manufacture, they can put them onto effectively a flat table and then stick your sandwich panel on. So it's prefabricated and sent to site.
Okay, great. And we had a couple of questions from Nicolette Havrish about the gymnastics of zoning and fire codes for these overbuild projects. She said, I suspect since in many cases you're changing the construction types, that there need to be rated separations between the lower and upper buildings. And can you speak to that?
Yeah, absolutely. The codes allow for it in Australia. So as long as we have a traditional transfer podium, concrete and steel, which is constructed that way, that's accepted. And we also have in Australia prescribed building codes to a certain height. We certainly wouldn't get the height that we proposed in the concept design. However, we could go for what's called a performance design. So we would actually submit our testing for the systems and solutions, and that would then satisfy the regulatory bodies and the certifying agents. And we believe that we can get through because we've already done a building like that. And that was the 55 South Bank project, which actually did change the use. It went from office use to accommodation, hotelier accommodation. So we do get away with it. I also think, and Jeff Spiritos will know more than I will, you can do the same thing in the United States. I don't know how high you can go. I'm not sure exactly what the mix is of the use or utility of the building, but I think you'd be pretty close to being able to do something very similar.
Awesome, thank you. So the follow-up there was, are you beginning to see cities changing zoning codes to allow for more densification in the vertical direction, as well as what was previously allowable? Or are projects for variances to get them built? Then I think you just spoke to that.
Yeah. And just to make a comment about the adoption of this particular approach, the approach is not new. Vertical extensions have been done for a long time. The problem has been the inhibition of the material types in some instances to get height, and not building the buildings with adaptability for horizontal adaptation or vertical adaptation. And this is the change that I think will happen. The capacity to build a building with the intent of a repurposed life or an extended life by going either horizontally or up vertically in the build structure will then start to change the genesis of it. But the big issue is we're only 1.6% globally in terms of mass timber products compared to wet concrete. And I think in the US, the latest analysis I did on what's called a Pestel analysis, which is an economic review of what's going on, you're less than 1% there as well in terms of adoption. So there's a long way to go. This is really the genesis. I think this is the point of promoting concepts and doing the thinking and promoting the thinking, that people have already started it, but how do we accelerate that, or how do we then create a genesis for something to move forward? And I think that's important. If I could also just answer the seismic reactivity, yes, this is one of the biggest issues for us. If you have an extension or an overbuild on an existing building, it's an easier thing to accommodate for that. And you do shift the center of gravity in the building, so you need to think about that. However, when you actually have sky bridges and you have other buildings and you've got seismic conditions, That's why we put in there, if your seismic conditions are above an acceptable calibration, it's advisable not to do a community, but it doesn't mean you can't do an extension. So some use of some calibration guide like that domains that we've created to scorecard the potential sites that you're looking at, including the country and the city. That's what you would use to be able to create that feasibility.
Awesome. Thank you very much. Some great comments, excellent presentations, thank yous, all of that in the chat. So thank you very much for your presentation today. And before you joined, I was describing how this being involved with this conference just helps me connect with all of these visionary people, and you're one of them. So thank you very much for all this information and this wonderful introduction to Sky Forest, Sky Land,
Sky Lobbies and Sky Gardens, and
Sky Gardens, yeah.
Sky Cities is probably the name that we probably came up with in the original concept. But Malay was the one that we settled on because of its Indigenous Australian roots, and we were doing it in Melbourne, so it had a great ring, bit of sizzle for selling the concept, which was great. And could I just also say, because I wasn't here at the start, but I want to say thank you to all of you. I've been associated with talking in this particular group for a number of years now, and certainly with Professor Cravella, I have to extend my sincere and humble thanks for constantly being a supporter. It's sometimes a lonely journey for anyone in mass timber trying to break through the noise and get a stage. And I think that you actually provide that stage for us to come and talk. And I think on behalf of all the speakers, and I think if Taylor's on as well, I think she'll find the same thing when she talks in person. It's very rare you get these platforms, and I just want to say thank you for that.
Oh, that's wonderful. Well, very glad to have you, especially twice now. It's wonderful.
No, thank you, everybody. And if you want to get in touch, please, take a screen grab, get in touch with me. Happy to have a chat at any time. And I wish everybody well.
Well, thank you very much. We just have a couple slides to close out. Sorry, Paul, go ahead.
I'll go ahead. Just thanking Paul again for everything you've done. And I explained a little bit at the beginning, right, about your goals in terms of first being on the forefront of getting projects built, the initial projects, right, in Australia and New Zealand, and then stepping back and looking at this at scale and thinking about how to think about many of these projects at a different scale. And so we very much need you and the team you have to continue working on these projects in that direction, because I think, it offers us the path forward. So thank you for your path breaking in that regard.
No, thank you, Paul. And I just hope that it provides some inspiration for someone to think differently and to explore the concept. Because when I think back, it's for almost 14 years now, my journey in mass timber, and even longer in engineered wood products. It was the genesis of changing in thinking that really created the conditions to be able to strive for the future. So definitely, I think that's the thing that I'd like to have a takeaway message.
Wonderful. Well, thank you again for a great presentation today. We hope that you'll all be back with us next week for the new edition of Mass Timber and What Can Happen during a webinar. We'll have Sandra Lupin from Michigan State University next Wednesday at noon, same place, same Zoom link. And just as a reminder, there's so many ways to engage with this community and the conference. And so please consider registering for the conference. The registration will close before our next Mass Timber presentation. Registration ends on February 21st. So there's lots of time for you to register between now and then. If you have students in your life, please encourage them to submit posters for the student poster competition. And of course, the Clean Energy Career Fair is open to all, both people who have potential careers and jobs available, and for those who are seeking jobs. So we have websites. If you go to Green Building after www.esf.edu, you'll be able to see all of those opportunities. And lastly, if you did sign up for needing a certificate of attendance, those will be sent to you shortly, and you can use that to self-report. And if you have any questions, you can always reach us at nysgreenbuilding@gmail.com. And so thanks very much, and especially to our presenter all the way from Australia today, helping to add to our geographic diversity of presenters and attendees. Really appreciate your time today. And thank you to Dr. Paul Cravella. Thank you all. Hope to see you next Wednesday, and then many more times after that in March. Thank you very much.
Thank you. Cheers. Bye-bye.